Hydrogen gas is a volatile fuel, ready to ignite at the slightest spark. Oxygen is the specific gas that fire needs to breathe and expand. Yet when these two explosive, fire-fueling elements combine in a chemical reaction, they produce cool, clear water. It creates a strange paradox. Two gases that feed infernos form the very liquid used to extinguish them. Water is a chemical compound. In this state, the hydrogen and oxygen atoms are chemically bonded, erasing their individual identities to create a unique, pure substance. This chemical bond replaces the elemental nature of the components, transforming two explosive gases into a single life-sustaining liquid. At the atomic level, elements combine by physically locking their atoms together like structural building blocks. Building water requires exactly two hydrogen atoms locked to one oxygen. Changing this fixed ratio alters the substance. Adding a second oxygen creates hydrogen peroxide, a toxic bleach. This rigid architecture gives every compound predictable physical traits, like consistent boiling and melting points. The numerical arrangement of these atoms is an unbreakable law, dictating the identity of every chemical compound in the universe. These rigid chemical bonds are distinct from common physical mixtures, like a spoonful of sugar stirred into a glass of water. The sugar crystals dissolve from sight, but their molecules simply float freely among the water molecules. Because they have not bonded, the sugar and water both retain their original identities. A true chemical bond is found in sodium chloride, or common table salt. Its raw ingredients are dangerous. Sodium is a soft metal that explodes upon contact with moisture, and chlorine is a dense, toxic green gas. Forcing these elements into a strict 1-to-1 ratio neutralizes their volatility. The resulting chemical reaction creates a harmless, edible crystal. In a mixture, substances simply share space. In a compound, they are locked by a bond that replaces their original behaviors with entirely new ones. Boiling can separate dissolved sugar from water, but the hydrogen and oxygen locked inside a water molecule are much harder to isolate. Simple physical methods like filtering or freezing fail on compounds because the chemical bonds are far too strong to be pulled apart by physics alone. Breaking these bonds requires decomposition. For water, the most effective tool is a direct electrical current. This is electrolysis. Electricity running through these leads tears the water molecules apart, separating them back into elemental gases. As the bonds break, hydrogen and oxygen bubble up into these measuring tubes, proving the dual-element nature of the original compound. Compounds function as singular pure substances in daily life, but with enough chemical force, they can be dismantled back into their foundation elements. These microscopic, fixed-ratio structures scale up from laboratory beakers to build the tangible materials of the macro world. The salt mounds in these evaporation ponds exist because of an exact 1-to-1 ratio of sodium to chlorine, a compound that safely preserves our food. The wet concrete pouring from this bucket relies on the compound calcium carbonate, which provides the rigid structural foundation for modern cities. The world is built upon these invisible mathematical bonds, transforming dangerous or mundane elements into the foundational materials of human civilization.